Right, welcome back to Advent of Code, and today let's take a look at day 21. And honestly, it was a really difficult day in my opinion. Um, and we'll go through let's say, the problem statement, then I'll try to explain what my idea was to solve it, and then how I actually managed to solve it. So the the problem sounds quite easy in the beginning, right? It gives us a number pad and it tells us that we need to input a password. So basically clicking on each button. The only problem is we need to use, or I guess the door to that keypad is depressured. So we have to use a robot to do the job for us. So the idea is we have to program the robot to move its arm up, down, left, and right on the keypad. And this one sounds quite easy to do, right? We just have to find the best path. The only problem was that we need to do this kind of recursive. It's like Inception if you think about it. So we need to use another robot to control the first one and then another robot to control the second one. And the problem with that is that if we try to optimize the path for the first robot, that might not be the optimal path for the last robot, let's say. And that was the problem that I faced using my approach. So again, if we take the second robot and it uses the first one to move around the hand and press on keys, it makes sense. It's kind of easy to do with only one robot, and I've tried to solve it with A star, and basically my get neighbors function was just up, down, left, and right for all keypads. And then the heuristic was, I tried different ones, but never really managed to get one that solved all the cases. So some codes I was able to, like, I was getting the right answer for them, but some other codes I wasn't getting the right answer. So that was kind of sad, in my opinion. So the heuristic function that I tried was, let's say, if like the difference between the number of characters, right? If I inputted 3 characters and the code was 5, then the cost would be 2, but that was kind of too generic, I guess. So I also tried to add some kind of distance from the current position to each other digit that I need to solve. That was a bit better, but again, I couldn't get it to find the best path for the last robot, and I think the solution should be different. Like, maybe the initial approach of trying A star wasn't good. Anyway, or maybe it is, but I haven't found the right way to use it, but who knows. So yeah, that was my initial approach, but as I said, it was kind of failing. So honestly, I had to cheat. It is what it is. Sometimes you have to do it, but I wanted to see like another idea. And the implementation is in Python, obviously, like the implementation of that solution was in Python. It wasn't like the first one that I saw. So, and I decided to use Groovy, and actually using Groovy was much easier than I expected. It felt like a bit of Java, but it's dynamically typed, so it's also like a combination between Java and Python. And what's cool about Groovy, from what I've seen, is that it has all of these functions like Rust has on lists, on iterators. So it has a bunch of itertools functions, right? And actually it felt like really easy to write the code in Groovy. It felt like a combination between Python, Rust, and Java. But you don't even need to use classes. You can just write the code like it's JavaScript. Like, you don't even need a main function. But yeah, let's try to go through this solution and try to understand how it works. And I've modified it a bit because I wanted to have like a class and you know, for both parts actually, like I can also go through part 2, and part 2 it's actually a larger chain of robots, so instead of only 2 of them it's 25, so that's the only difference. Yeah, again, so if my A star solution would have worked for part 1, then I think it had no chance to do part 2. So yeah, I mean, it is what it is. So first things first, we define here the positions mapping. So this is basically, if we take a look here, it's how we convert each digit to its position. So 7 is 0, 0, and A here is like row 3, column 2. So that's the idea, row 3, column 2. Yeah. And I have this vector class, which is just used as a tuple, let's say. Right, so then for the main part of the algorithm, and let's try to go through it. So we have here a moves set, and basically we have the start position on the keypad and the end position on the keypad, and we also have a set of well, I guess it's only one, because there's always, like if we look here, it's always only one piece that we need to avoid, right? It's like blocked off. And the reason why it started with the A star was because of this idea of, oh, we have a path and obstacles. It made sense, but for some reason, yeah. But whatever. So we want to get from start to finish. What do we have to do? Is to compute the delta, and basically we are gonna move up, down, left, or right based on the delta, right? So it's just doing like the Manhattan distance between the start and the finish. But then came the trickier part, which I'll be honest, no idea why it works. I would have to see maybe like I mean, even if I see the simulation, because I did a simulation with A star, and you know, it makes complete sense, right, to do the pathing. But why does it happen that if even if we get the right path, the optimal path for part, like for the initial robot, why do the subsequent robots fail to get their optimal path? And I thought about a few reasons why that might happen. One of them was maybe if we keep these operations as grouped as possible, then we might have to do less, like if we get to the point of just calling of or just pressing a lot of times, and then just making really small adjustments and then pressing A again a bunch of times, I think that's gonna lead to like the best solution. So maybe the thing that was wrong with A star was that it was generating like really random paths sometimes. So you can see here how it looks like they are really grouped, right? Like every time you had to do like go down, it only went down, or here it went up all the way and then it went right. It didn't do zigzags. So I think maybe that was the problem, but yeah. And here is the part that actually solves the entire problem. I guess that's it. So if we don't have any moves between the start and the finish, we just hit the accept, or yeah, I guess accept. Otherwise we have to generate some permutations, and I guess the permutations are gonna be basically mixing up these symbols. But as I said, I think the best one should always be when they are grouped together, so who knows. But yeah, we're trying. I guess, yeah, exactly what it does is just generating like all the possible permutations of these symbols. So all the paths basically. So these are all the paths that you can take from start to finish. And yeah, I guess in the end, that's what you actually have to do, generate all the paths instead of trying to find the best one, because maybe the best one right now is not the best one overall. So yeah, maybe it was like a DP problem after all, so not really a search one as I hoped. I mean, it would have been really cool to have it solved with A star, but it is what it is. Yeah, anyway, so here we generate all the possible paths from start to finish. All right, so imagine we had basically, let's say, this string, for instance. So we could generate like a lot of combinations, right? We can just move this one at the end or here, then we can move this one here and so on. Right? There are a lot of ways to get from start to finish in that. And here is the min length, which I think, yeah, basically it uses move set. And of course, as like if we don't use, we can try to not use memoization, but that's gonna be really slow. So this is like the recursive solution plus the memoization added afterwards, right? So just to optimize it. And yeah, basically I guess initially, so when depth is 0, so for the first panel or look pad, the point to avoid is 3 0, so this one in the bottom left, and afterwards all the other pads have the obstacle at 0 0, so that's the position to avoid, right? And depth is the lock pad that I guess, yeah, lock pad. Anyway, so then based on which lockpad we are using, we start at a different position. So capital A is for the initial lockpad, this, and lowercase a is for this lockpad, right? And here I used long, but I think int should be enough. Not sure. Haven't tried it without it, but it is what it is. And then for each character from our code, we have to try to get from the current position to the character. So imagine that initially we start at A and we want to reach, let's say, I don't know, 2. So we are gonna generate all the paths that go from A to 2, right? And from that, what we have to do, so we generate all the paths that go from A to 2, right? So we're gonna have all the paths. And then that is gonna give us moves that use this thing. So if you think about it, this will represent the new code that we need to solve. So we have to recursively call the min length function, but instead of like saying, okay, let's use the suffix of this code, we are gonna use instead the first move and then the second move and so on from all the paths that we can take from A to a number, right? And that's gonna be like move left and move up and move left. So those are gonna be passed into min length recursively, right? And here is where the memoization comes in handy, because that is gonna return a number that represents the path. So if we compute the same kind of path multiple times, then it doesn't make sense to compute it every time. Like if you move from here to here, it's the same as if you move from 6 to 8. So it doesn't matter, it's the same length. So that's what we memorize here. And again, we increment the depth. So we go to the next robot on the chain. and the next robot on the chain has to solve the pathing for that specific, only for that specific piece of like of the code from start to the next point. And yeah, I thought about this one too, like maybe A star failed because I was trying to complete the entire path and then move to the next robot instead of doing the path bit by bit. And I also wanted to try to return from A star all the possible paths, but that's not kind of how A star works. A star usually you just get the optimal path. And what other algorithm I could have used to get all the best paths? I think Dijkstra, right? So yeah, I could have used Dijkstra and get all the best paths, but let's imagine the first panel, let's say it has 10 ways to solve it optimally, like 10 ways to solve it in the best way. Then the second robot would have to try all 10 paths. And let's say one of them is bad, two of them are solved in only one way, and 8 of them are solved in 3 ways. So that would increase it like 20 something, right? And then the third robot would also have like some kind of increase here. So if you think about it, it would just exponentially grow, and once you get to 25 robots, it's already in the millions of checks. So yeah, I guess that wouldn't have really worked. Like part two, yeah, I mean, if that worked and then I saw part two, I would have been like, oh shit, here we go again. Here we go again with the, I mean, I would have been, that would have been like, you got tricked kind of. It was like the problem from before, the one with the stones, that was pretty obvious that's gonna happen, so you know, didn't get tricked. But this one wasn't really obvious that it's gonna say, okay, use 25 robots. I guess now that I think of it, it's kind of obvious that was gonna happen, but it wasn't at the before. I mean, of course, after we see part two, of course, we are like, oh yeah, yeah, I knew. Sure, sure. But I guess that's what made sense to do. I mean, again, as I said, the A star solution was a bit harder to implement. This one was a more straightforward one. I kind of had it in the back of my mind, but I couldn't. I was like, okay, A star has to be the solution, but no, it wasn't. We just had to do the recursive approach and solve it only one key press at a time. Honestly, I thought it's not gonna be efficient enough, but you know what I missed? I missed this part. I didn't think about the memoization part because I thought that, okay, I can do it recursively and try to solve only one key press at a time, but then I solve one key press, right, for the first robot. That's 2 steps. But then the second robot has to do 2 steps just to solve the first step of the first robot, and then the third robot would have to do like 10 steps. So I was like, oh, it's gonna increase really really fast. So but I missed this part with the memoization, which would have really helped if I realized that I can do this from the beginning. And I just tried the recursive approach because yeah, the recursive approach is just that easy. And also like finding all these functions for Groovy, I had no idea they existed, but I mean, pretty cool that I actually found like, yeah, it's a pretty good language if you have to work with arrays. Like inject, it's a weird name for fold, but it's like a reduce function. But Other than that, yeah, like of course the solution made sense. And yeah, the part 2 solution was just changing the number of robots to 25, so yeah. So yeah, I guess that was kind of it for day 21 in Groovy. I mean, of course, these 2 days, like day 21 and day 22, should be the most difficult ones. I would say the difficulty in this one, yeah, I'm not sure. Maybe it came just from the fact that I was too tunnel visioned on just trying A star and not really going for the easy approach first. Which, let's be honest, if I try to do the recursive one and I saw that it's too slow, I mean, I already talked about doing memorization and DP in one of like 2 days ago, I think. So probably I would have remembered my own advice to do memorization, so maybe I would have tried it. But yeah, the important part was even if I mean, I thought about it, but again, I was like, oh, it's gonna be so slow, it's not even gonna, let's not even think about it. So yeah, that was the main issue. But I mean, the language itself, Groovy, pretty like definitely. I mean, it's dynamic, so I don't really like that thing about it. But definitely, I would rather use this one than Java, to be honest. It's much better. But I mean, it's much nicer to write code in it. But you never really hear about Groovy, right? It's like a really obscure language, but it's really like much nicer than Java. So yeah, I mean that's kind of it for day 21. Bit trickier, but yeah, I mean the solution wasn't that hard to write. I mean, after you get spoiled by the actual implementation, it's obviously it's not hard, but yeah, coming up with this idea itself, uh, honestly, I was like, oh, it's gonna be way too slow, and I just skipped it. So my bad on that part. And yeah, I mean, it's a decent solution, but let's see in the next one.